Hi, and welcome to IoT North. I'm Paul Wheels, the founder of IoT North, in a little bit of a fluster today, as I've just got back from a nice little trip. We've got a great talk with Andrew Blantz from Waterstones today, talking about getting anything from data. I'm going to bring in John and Andrew. Hi, guys. How are you today?
Hello.
Very good, thanks.
I am good, yeah.
You're good. John, what have you been up over the past month?
Just having a little look at the security announcement from the government yesterday. So there's a big announcement of the Product Security and Telecommunications Infrastructure Act 2022 now in draft that everyone's going to have to comply with in a year's time. So there's something on passwords in there, no default passwords, and then on reporting security issues, and then a minimum security update period for all IoT devices. So have a look at that if you get a chance, because you're all going to be complying with it in a year's time.
Joy, more work for everybody. Andrew, what have you been up to? I believe you've had a bit of a role change at Waterstones.
Yeah, so at Waterstones, I originally was the data scientist there, but recently my job has turned into what we call innovation consultant, which is maybe a slightly less defined term, but that is now what it says on my LinkedIn page. So it's definitely official.
So how does that change? How does that role change for you?
So I guess when we were doing data science work, it was still quite about building proof of concepts and understanding how we could apply data science to our challenges our clients face. So I guess my role now is slightly broader. So it's not just looking at data science problems, but more agnostic than that. So about robotics or IoT, which this talk will be about. It still includes AI and things like that, but we're running lots of different exciting things now as well.
And what kind of customers are you finding that are really leveraging your skill set with that new title and more broader scope?
So Watersons, we work with lots of architects and people in construction. So a lot of them are interested in things to do with robotics and IoT because there's predictive maintenance problems or entering hazardous environments. So robots will be interesting there. IoT here, we work with lots of social housing. That's where my talk's going to be about. But also things like interesting ways to visualize data. So we are interested quite a lot of like immersive sort of AR and VR technology. So can you put BIM models and then display them in interesting ways? Can you work them in real time in sort of interesting environments like headsets and things like that? So it's quite a broad range of clients actually we get to work with and try to apply interesting, exciting emerging tech to.
Yeah. Are you finding customers have available budgets to make those investments on the sort of R&D side of things, or are you finding the market being a little bit more hesitant on
it? So I guess as we're finding our feet of what our strand or how we define our strand of innovation consulting at Warsons, we're also trying to probe that question as well. And there's definitely like project work that can be fairly scoped up. We will deploy this set of IoT sensors, a proof of concept, or we will make you an AI model that looks like this, which is so much excitement around these topics that I think there is areas for budget there. But yeah, it's definitely a challenge right now to figure out maybe how to do the maybe more workshopy thinking, self-consulting rather than just purely deploying a project.
Yeah,
that's the excitement, figuring it out.
Yeah, exactly. Do you think the opportunity with like I've noticed there's a few meetup groups starting to pop up now in regards to low code, no code type offerings and stuff. And do you think from your experience that tools and platforms like that, where you can actually get customers to collaborate more intrinsically with the experience, do you think that will help with the scale and growth?
I think in the long term, yes. I think there'll always be a place for, programmers and people who can write code. It's definitely interesting seeing how far low code, no code tools have come. I was at a conference recently and they were doing like Azure and Microsoft's product about that, the Power Apps, and I was actually amazed at how fast you could build something like a full app on a web page in just 40 minutes. She did it in real time in front of us. I think reducing that barrier of entry to proof of concepting, this idea of I want to see what this app will be like and I want to know really fast, that that's definitely valuable, and broadening with people who have access to that and can do that is also going to be helpful. But yeah, I don't think you could ever fully replace like a skilled programmer right now, even if like AI and stuff are sort of poaching into that areas.
I feel my job is safe.
Well, I think
all our jobs are safe. That's
yeah, I agree. Though I think I do represent in my day job, and just have to do the thing of my views on the show with IoT North are my views, not of my employer Intel's. Parking that statement aside, from my experience, and we do offer the product that I represent, Intel Getty, is a low code offering, right? But it does not remove. It's a module that's been a barrier to adoption because of the time and complexity that it helps with that, to help the scalability side of things. That actually it still requires a data scientist to help and guide. And responsible AI will always need that. We do need to take that responsibility in consideration, making sure that we know how the models are created and so on. And I think, the whole ChatGPT explosion of interest in AI and the expectations of AI being a leap forward to what people thought was where we were at to where people think we're at now, is quite an interesting thing. But it's evolution. It's like when people said, when people moved from typewriters to PCs, then the fear is there that it opened up opportunity with that evolution. And personally, I think what we're seeing in the market and the technology evolution, yet again, is a big leap of evolution in this space.
I mean, some of the tooling around data science is becoming just amazing now. You got auto ML, you just sort of fire it at some data and it tries successive models through it, from like regression, categorization, neural networks to work out what the links between the data are.
Yeah.
So you need very little skill to get a model out of it.
Yeah.
There's with something like Getty as well, just to plug your product again, there's something interesting about reducing the barrier of entry. It allows people who are experts in another field to enter into this area. The something like, oh, you are a doctor and you want to train the data set, you want this is the breaks, this is the interesting bits of the x-rays. That would be very hard to do if you didn't have a tool that was approachable to everybody. And you also mentioned the rise in the number of meetup groups. I think that's also a really great thing, especially like here. Do we all classify ourselves living in the North? Leeds, that's kind of the North, right?
Leeds
as well,
definitely North.
Kind of North. I think the people who live in Leeds definitely consider themselves to not live in the Midlands.
Yeah, everyone considers themselves living in the North if you're above London. But yeah, the so many meetup groups, so much action in the community. It's really exciting.
Yeah.
As someone who used to live in Aberdeen and before that Shetland, this seems very far south.
This is north.
This
is quite north. Yeah.
It is. We've got a couple of questions popped up. So we've got one from Charles. Hi, Charles. Are the customers mostly public services or private companies? I think that's steering to you, Andrew.
Yes, I guess we work with lots of different people, like charities and universities. But I guess lots of people I interact with are actual private companies. So yeah, architects and construction companies, engineers, things like that.
Yeah. And another question from Dick Wallace. Hi, Dick. Great to have you on the show again. A BBC Click program this week warned of dangers of AI. Any comments, Andrew? I didn't see that, but I will check it out.
I didn't see that, but I always see the people who host the Click program at conferences in Scotland and around the country, and it makes me really want to watch it. They're so like excitable and charismatic. Yeah, I guess there's an element of something like Chat GPT, this understanding of, is the thing it's outputting actually the truth? It's very confident at creating lies. And if 90% of stuff that's coming out is truth, how do you determine what that other 10% is? Which makes it quite scary if you're trying to automate things with it, trying to write processes that, that you're pretty sure a human will overlook. So drafting things, summarizing documents, potentially good use cases of AI. But there is some quite scary things, like not knowing exactly what data the things were trained on. So not quite knowing the biases in the system, because all these systems can only reflect the data that's gone into them. Understanding something as vast and sprawling as GPT-4, and it's not opinions, but the biases it will produce and how people will accept it. That's quite scary. And then I guess there is this sort of element of people kind of trust these things, I think, because it's very easy to humanize them and sort of act as if they're anthropomorphized somehow. It's a hard word to say, but like little things like people say they hallucinate, which is something a robot can't do. That's something a human does. Or they, whenever you talk to some of these chatbots, little dots come up as if you're talking to your friend, waiting for them to respond. So these little things sort of trick your brain into thinking, oh, this thing's a trustworthy source of information. That's a lot of downer comments, but it is a really exciting piece of technology, right? It's pretty amazing how far it's come in the last 6 months. Its ability to generate things is probably way better than anyone would have guessed 2 years ago.
Yeah, I think, as you know, as I think I touched on previously, that with every evolution of technology, there is always a little fear, concern, and such. Like I can totally appreciate and empathize with some of the interested in animated conversations I had at dinner on Saturday night with some friends. Some people want us to shut up talking about AI. Others, we were definitely a split table on was it good or was it bad where we were at with it currently in regards to the responsibility of it. And I think you're quite right. You know, it all goes down to the data set. And I think we all experienced, if we want to believe it or not, the impacts of manipulation of data with not too distant elections in the Western world. There was definitely impacts due to manipulation of data and steering of people's mindsets and stuff. I think
apparently the team that deals with that at Twitter have been made redundant, incidentally. So
that's Twitter. There's still other social providers that we will not talk about because they use those channels. But you know, it is that thing about, you know, maybe the world does need to be taken a view of responsible AI and having procedures in place that need to be followed with it. Question for you both: do you think we should take a 6-month break before we move further ahead, like has been requested by the likes of Elon Musk?
I think the hype curve around AI is particularly high. We've never seen a hype curve quite this big. I think it'll just work itself out. You know, like any new technology, there's the promise, and people work out that the promise is not really going to deliver what they think or fear. And that'll just happen naturally.
Yeah, I'm not sure you can really put the brakes on something like this now. I'm not sure how you could reasonably stop these companies developing things with it. I think, as you kind of said, like, John, people will realize that these promises they're being told, like if you go on like LinkedIn or Twitter or any other social media platform you can use, there's lots of people being like, this is going to replace all your jobs, or if you're not using this right now, your company is going to go bust. And people will realize that is not the case. But it's kind of what you said, Paul. There's this thing of like truth in the media. What is true is kind of a silly example, but and I kind of thought I'm kind of, you know, I know how these things kind of work. I've worked with them. I've been a data scientist for a while. I kind of thought hopefully I wouldn't get tricked, but one day I saw a picture of the Pope wearing a really nice jacket, and I was like, yeah, cool, the Pope has a nice jacket. And it turns out it was AI generated. So there's like, it's going to be a really interesting few years as our trust in images and videos. I'm not sure what effect that will have, but
yeah, I mean, deep fakes is a specific issue that, you know, people have to work out images they see on the internet. Is it real or has it been fabricated? And that's been a problem since the beginning of Facebook, where you've just had lots of fake images being made.
Yeah, and that's it goes down to the responsible AI and the responsible use of it. You know, I mean, even Adobe's recent releases, which are absolutely phenomenal in helping you generate and create content, to the point pretty much anybody with an iPhone or high quality mobile camera phone is going to be able to make near enough film level quality movies with explosions and backgrounds and all sorts of stuff at very, very low budgets as well. The thing for me personally with AI that I've been really looking at beyond everything that I do, my day job is actually, you know, chatbots and being able to give really accelerated access to data by plugging into Jira and stuff for solve tickets, and being able to steer with the data sets that it's using to be able to create a very easy interactive engagement with customers to solve problems much more efficiently, which then delivers a higher quality of product as well. And I think that potentially could help startups quicker than existing businesses, because they'll have that leap ahead. They won't have the how can I put it, the risk adversity, because once you get to a certain size, you get terrified of being sued. Whereas, you know, unicorns, I've got nothing, so you can't take anything. We've got a couple of statements here, and then we will jump onto your talk, Andrew. But this is great to see the engagement and stuff. So I'll jump to Tin. Find ChatGPT is a helpful tool for disabled people. I am looking for using AI for improving accessibility for disabled people. Any comment on smart cities in the Northeast for accessibility? Interesting. Funnily enough, I do know of a number of companies that are creating patient support robots that can do the basics of caring for their patients, to enable nursing staff to focus on more critical stuff to help alleviate the overworkload they have, and that side of line thing. In regards to smart cities in the Northeast for accessibility, I'm not quite sure what that question is, to be quite honest. We've got a number. I'll jump forward. Jamie Stone, is the AI fear allowing it to create its own unguided subtasks? Having an AI spotting potential shoplifters is an IoT area I can see going very wrong. Well, there's still going to be a human in the loop on that, because there's still going to be a person that's going to be accosting that person, that the data set and everything and the legal procedures that we have would kind of counteract that, but it may speed up the process of identifying people who are prospectively shoplifting. So another one for debate from my side. Andrew?
I guess this is the issue. Like, comes down to what is the data set being trained on. Like, I don't have specific examples, but there are instances of people of different races and skin tones being, you know, identified more or less by AI algorithms. So this is definitely kind of a scary topic to let it make decisions in, right? I think it's there's a lot of responsibility here to, you know, on the developer to make sure they know what they're doing and really understand the areas where these algorithms can go wrong and the biases they have, and the areas that they actually are having these biases in. I think that
there was a product that developed like a hand dryer, and they used AI to recognize hands being placed underneath the dryer, but they'd only used white hands to test the system, so the system was unable to recognize any other skin tone, which was a little regrettable.
But it goes down to Andrew's comment earlier, though. It's all about the data set and really planning ahead, thinking about those broad scopes and considerations, rather than building on, you know, small data sets and continue to do that. You know, if you think about sort of a proof of concept, proof of value type side of things, you may start with a much smaller data set, but you need to be able to always have at the forefront of your mind, this may accelerate. And if that's the core baseline of that model, having those points covered, that when it goes to the next phase, these need to be included as well, just to cover things and be responsible with it.
On this point, I don't think you can create a model without bias. A great quote I heard is, to human is to bias, to AI is to bias systematically.
I quite like that. I think we should get that on the t-shirts for this year, John.
Yeah.
Okay, Andrew, let's thanks very much for the engagement. Please do fire questions ahead if we have time at the end. We will have a cut off at 7 p.m. tonight. But Andrew, over to you. Really looking forward to your talk.
Okay. So I have two screens and I can see myself in this one and the things on that one. So I'm going to try my best to focus right on this screen. Okay. So sometimes when you're trying to make data-driven decisions, it can be really hard. Maybe every time it's really hard, actually. And this can be for loads and loads of reasons. But a few might be you just don't have enough data to make that decision, or the data isn't coming in fast enough. Maybe you need to make a decision every minute and it's only coming in every week. Or that the data you are getting just isn't very good. It's got errors in it. Columns are just named wrongly, and you have to spend so much time changing and perfecting your ETL processes to actually make the data usable. Another issue, though, can be that you just don't have the data you need at all. It's not in the data set. You know it exists somewhere, and you can't really proxy it very well. But you know, if you just had some kind of device to pick it up, maybe you could actually make this decision. So that's what this talk is exactly about. It's about using IoT devices to go and get data that you don't have access previously to make decisions. So I'm Andrew Blance, and I work at a company called Watersons, and that's the logo on the left of the screen, my left, the little W. Here, I used to be a data scientist, helping our clients solve data problems, building predictive algorithms, and trying to understand ML ops pipelines. And over time, I switched into a role that we call innovation consulting. Watersons generally is very innovative, but the sort of innovation that I focus on are about step change, big, exciting new projects using emerging tech. So to do this, we typically want to partner with other people. So whether it's startups or research institutes or universities or other innovation centers. And we'll use this to sort of bolster our skills so we can solve challenges our clients have we typically couldn't before. So we have lots of fun, exciting examples of that right now. We are currently working with an engineering firm to try and get them robot dogs to allow humans not to have to enter dangerous environments. They have to clean out lots of buildings with asbestos. Now, wouldn't it be great if a robot dog could go in first to check how dangerous it actually was? We are working with a law firm to use AI to try and generate drafts of documentation and find errors within documentation they write. This will help paralegals save time and be able to do more useful and valuable tasks for their clients. We are also working with architects to use the same technology Disney used to make The Mandalorian to find exciting new ways to show and display the amazing buildings that they make. The project I'm most proud of, though, is the one I'll be talking about today, which is all about making social housing homes safer using IoT to try and stop mold growth. This has been a really big journey for us. So a lot of this talk is talking about how do you go on that journey and how do you make these relationships and where should you start if you want to take on a task like this. Outside of work, the little symbol on the right, up on my screen at least, is I and my friend Alex, we run a podcast called Brains on the Outside, where every week, every Monday morning, we pitch really ridiculous and stupid and wholesome business ideas. Ones that are way too weird and innovative for actually us to do at work. Things like, could you have a tap that has gravy in it? Really good stuff like that. On top of that, I co-host the Northeast Databricks meetup. Databricks is a big data cloud platform, does data engineering and data analysis and data science and machine learning. It ties everything together, super fast, super cool, very cool right now. We host a meetup every 2 months in Newcastle. So if you're in the northeast of England on June 8th, come and say hi. We have pizza. We have Gavi and Luke talking about geospatial data in Databricks and how to do machine learning projects. So, as I said, this strand of innovation we're doing, this idea of using IoT devices, is quite new to Watersons. So this project is going to be, this presentation is going to be looking at how we did that, why we're doing it, and how we started there. So this, you might know what this is. This is a data maturity curve. Consultants love to trot these things out. If you ever talk to a data consultant or see another consultant give a presentation, they will probably show you a data maturity curve exactly like this. There'll be some horizontal line, the vertical line going from a corner to a corner with words like, as you see in my screen. But we do love it for a reason. They're quite good at sort of helping people think about where they are, their progress of using data. So right at the bottom On the green line, these are Washington's branded colors. I'm being a team player today. On the bottom green line is nothing. We speak to lots of people who are really excited to do AI and use ChatGPT and all these exciting, amazing things. And you talk to them, how are you gathering your data? And it turns out they're running around factory floors with clipboards, writing it down on pieces of paper, and then losing it forever in a filing cabinet somewhere. That isn't going to help you, become data driven, having all this information lost. So here in your data journey, you're doing something like that, but you have ambition. The next stage is doing ad hoc analysis. So you're using something like Excel to do one-off pieces of work. What was my finances like last month? Copy paste. What was it like next month? The next stage is you do BI. So you use a tool like Power BI and you create a single source of the truth and your Power BI dashboard can pull from, and you can do more repeatable workflows. From there, as trust in data grows within your company, as the story goes, you can now use this data that you have curated and treat so well to make predictions. Now, as those predictions are hopefully correct and people get even more trust, you can automate this whole process and take automatic action off the decisions you're making. This sounds great, and everyone really wants to be in the top right. But this is actually a really long and difficult journey. And it's easy to forget that this isn't really a technical journey. This is a cultural journey. It'll take a really long time for people to get on board with this and adopt these methods and really trust the data and the decisions it's trying to make. But sometimes I think you can skip this journey and go right up to the side. Can you, in very specific instances, if you're really sure about the scope of your project, can you drill down into one decision you want to make? You don't want to make automatic decisions for your whole business. You want it one very, very specific place. And in that very specific question, you'll do your automatic decision making there. So this is kind of the area we are using our IoT projects in. Very targeted deployment of IoT devices to answer one very specific question. So an example where we started off was looking at manufacturers. A specific one, they do they work with timber. They cut up really big logs and they make the logs smaller and they sell the wood. Now, if you work in this industry, you go to your trade conferences and you read your magazines, and everyone's talking about Industry 4 and how if you had this brand new saw with Bluetooth and Wi-Fi and sensors and the blockchain in it, your whole life would be better. You'd be way more efficient. And if you don't have this blockchain Wi-Fi saw, you're going to get left behind. And you might think to yourself, why do I need a blockchain Wi-Fi saw? And you don't really know the answer, but everyone else wants one. And you can kind of construct some argument in your head of, well, if I was able to get the data out of it, maybe I could understand when it was going to break and I could do predictive maintenance. And so you think of it like that, well, I could buy this new saw and I could do predictive maintenance and I could know when it's going to break. Why don't people just do that? Well, a lot of the times their old saw works perfectly fine. You have a £15 million investment to buy the new saw. You don't want to do that. You can't afford to do that. So you're stuck between this rock and a hard place. You want to be able to do the predictive maintenance, the useful bits, but you can't just buy this entirely new piece of equipment. On the other side, you have this market pressures to become more efficient. Your customers are expecting you to become more advanced, and you're locked between these two things. So this is where being super targeted came in. We were talking to over a year ago. It was I think it was SMAS and maybe Cambridge, which is actually a weird combination now I say it out loud. But they were talking about a concept called shoestring IoT. This idea of not big, expensive deployments, but very targeted. Can you use things like Arduinos or Raspberry Pis to gather hyper-specific information? Instead of buying a new saw, can you just use an accelerometer to measure the vibrations of the saw and use that as the predictor of whether your saw is going to break? So we got into this idea and we started thinking about IoT devices to use. And within IoT devices, I'm talking to an IoT audience that are experts, so you might disagree with my statement here, but I view them being on a maturity curve as well, in a sense. At the bottom left, you have something like Raspberry Pis, these small devices you can work on, and you get more mature, or maybe the equip. Well, not matures, the equipment gets more expensive. You get these ad-link neon cameras, these edge computing devices. These have huge amounts of compute on board, so you don't have to do your computation in the cloud. Sorry, you can do it on device. So you can put this camera somewhere where there's no signal, or you can put the camera maybe on a boat somewhere in the North Sea, and it can still make decisions. And as you get even more advanced and even more expensive, you can make those edge computing devices walk around. So we're interested in a lot of these things, but for our current purpose right now, what we're actually really interested in is the Arduino. Can we use an Arduino with a Raspberry with a accelerometer on the side of it to predict the saw breakages? All these things come down to an appetite for risk. How expensive a piece of equipment are you wanting to get? Now, that can be balanced of the riskiness of the project. How likely is it going to fail? Has this been done before? But also maybe the size and scale of the problem. If it's a big problem, maybe you're willing to push forward development further. In the end, our saw project didn't work out, actually. We couldn't get this balance to work out. But it set in motion a lot of ideas in our head of, well, we could use really targeted deployments of IoT devices to solve very specific problems. And this idea of using microcontrollers like Raspberry Pis and Arduinos were kind of now lodged in our head a bit. So, as I said, we work with a wide variety of clients. One of them is social housing companies. Right now in the social housing sector, there's a really large problem that they're being regulatory and ethically forced to deal with. And a lot of social housing social housing stock is a really big problem of damp and mold. There's a really tragic story last year in the news of a small boy who actually died in a social housing house. And since then, the government has been really demanding answers from these companies. Now, a lot of the people we talk to, the social housing companies we work with, they are really, really keen to solve this. They are very ethically driven. They understand the responsibilities they have. So they're very, they're willing to spend money and understand how to solve this problem. Now, you might just think, well, surely this is a solved problem. I can buy a mold sensor. I can buy a humidity sensor and put that in my house. But actually, we found, and the industry believes, that current solutions aren't adequate. Typically, a humidity sensor goes in one room of your house and sends data out. And that's great. That's what you'd expect. And you could use that data to detect mold or not. However, that one sensor isn't going to help you detect mold in a different room. So firstly, you need a product that can actually detect the entire house, some kind of mesh network of sensors. On top of that, we want to prevent the risk of the mold growing. It's not enough just to send the data out there, but we want to be preventative as well and cut through all the potential bureaucracy that might be involved and the difficulties that they traditionally face to get people out there. So a bit of this has to be then taken action off the back. Can we then control the boiler in somebody's house to reduce the chance of mold growth and have the social housing companies actually absorb those costs? Because partly it's the right thing to do. So here on one side of the rock and a hard place, I was very happy with these emojis when I found them. We have this mounting regulatory pressure to actually make sure this problem never happens again. On the other side, we have current costs of deployment of IoT sensors and the current technological barriers as well to do a product that can solve all the issues at once. On the other side, there's societal and marketable pressure to solve this. And also, maybe most importantly, the ethical obligation that they have to look after their tenants. A social housing landlord isn't like the landlords that own our houses. A social housing landlord has an extra moral and ethical obligation of care, a duty of care over their tenants. So this all projects where you are helping them out and looking after them are part of their remit. And that is a view that our customers share and want to move forward with. So the goal for the rest of the talk is, can we make social housing safer by de-risking the development of low-cost and non-intrusive sensor systems? So we want to make it cheap. We want to make them not be risky for people to buy. We want to understand how to build these systems, because that's not something we've internally done at Warsons before. And when I say non-intrusive, I am talking about, well, you don't want some random guy coming into your house every week to top batteries up and, cables dangling everywhere, and you don't want them connecting to your Wi-Fi, and you want to feel safe that the system is actually working, especially if we're going to make claims about attaching into your boiler. So there's a lot of moving parts here. So we'll start with the hardware, which was kind of where we started. Now, as I said, we had Arduinos on the brain. So I think this is actually a Raspberry Pi, but you get the idea. Now, we started developing this ourselves. It was about a year ago. Got a soldering iron on in the office. Had to go sit outside so the fumes didn't go everywhere. It wasn't raining, so it was okay. But, we had a Raspberry Pi and a breadboard, and on it as a 3G hat, so we could connect to a Zero remotely, so it didn't have to be on somebody's Wi-Fi. We had a big battery, so it didn't have to plug into the wall. And we had a humidity sensor as our first prototypes. And this started the work. It was actually harder than tutorials make it seem to actually get things securely connected to Azure. That was on the Arduino side, not Azure side, getting all the security certificates worked out. So in the end, we had a breadboard with wires and an Arduino on it, and I was very proud of it. But we looked down, and it kind of looked like an improvised explosive. And I imagined trying to take that into somebody's house, and I imagined getting chucked out. And we started to realize that the gap between Arduino on breadboard to production quality unit is enormous. And it really enforces the idea that we're not a hardware company, we're a software company. With this, we solve business problems with software. So we went out and we bought some pre-made stuff. This is a Monet sensor, Alta device range, and we quite like them. They have this central hub that we see the picture there, and that can connect with over 3G to their cloud network. So that connects into the plug socket into the wall, 3-pin plug socket, 3G up to cloud, and then that goes into Azure. And then from that, you can wirelessly connect other sensors. So here you can connect wirelessly a humidity sensor into this hub. And this is really great because these sensors have extremely long battery lives. The humidity sensor ranges between 5 and 10 years, depending on the settings you choose. So this was kind of solved a lot of our issues around non-intrusiveness. Doesn't connect to your Wi-Fi. There is no cables dangling, and we're effectively never going to have to come and change the batteries. However, buying lots of these started to feel a bit expensive, and it wasn't all we really needed. There was an ethical component to it of the safety. How do people trust these systems? So we thought about it, and we began reaching out to partners to help us understand how better to utilize and build hardware. It's worth noting that in the prototypes going forward that I'm going to show, the data is coming from this. However, that's not the end goal. The end goal is to produce our own hardware. So we are partnering, we're in conversation with the Institute of Safe Autonomy at York University. This is a research group that, though they work in safe autonomous systems effectively, robotics and sensors and anything that takes an autonomous decision, and they try and understand how to do that safely, in the sense that the decision is making it safely, but also that the people side of it is safe as well. So safety and trustworthiness is big focuses for the Institute of Safe Autonomy. We're in conversation with them and going through certain funding rounds with them to build hardware prototypes of mesh networked humidity sensors that can send signals to boilers. So this is kind of in its early days, but we're hoping to have prototypes soon-ish. But the really good thing about this is we also have access to their ethicists and philosophers and the people who can do the societal thinking and talking to government. Because, as I said, having a sensor in somebody's house is quite a private and potentially intrusive thing, even if you don't want it to be. You have so much trust in the system and understand and make assurances and guarantees that you're not tracking them or you're not somehow fiddling with their energy bills. So it's a very complex system we're building up. So our hardware goals revolve kind of around the ISA, but for right now, we are working with these Monet sensors we found. So the bulk of the talk now is our software stack. We are primarily Azure developers. I work a lot with things like Azure Machine Learning or Azure Databricks to make machine learning and AI tools in my data science job. But I've done a bit of work now through this, through the IoT hubs and event hubs. But we have a whole team of bespoke software developers who are excellent at creating production-ready systems, and we have a whole lot of data team people who are excellent at making scalable data solutions. So this is kind of a task we're sending them on. Using Azure as well is really great because it means we can integrate the data that's landing into other existing solutions they have. Having the data just be about purely humidity of the house, while it's very, very valuable, might be more valuable if we can filter that through stuff like mapping data, geospatial stuff, tenancy information, the age of house, the stuff they'll have on internal systems that might already be on Azure. So we're very interested in moving things off of proprietary systems and into a more of a unified solution so we can look at things at a broader, grander scale. So we started thinking about the stack we'd use, and we're in Azure, so there's a few touchstone parts of Azure you'd probably use when deploying IoT sensors and thinking about event-based data. So data that comes in, maybe on trickles is the right word, but like humidity readings, accelerometer readings, drips like that. So you'll start off on the left-hand side for me, hopefully it's left-hand side for you, an IoT hub. And as data trickles through there, we get it cleaned up and into the what we call the generic event handling space. So here, data, whether it's sensor data or maybe data from somewhere else, so weather data could all be combined into a generic place so a developer could pick it up from there. At this point in the middle section, I'll go over this in a lot more detail shortly, but I'm giving a broad overview right now. In this middle section, a developer doesn't need to care about where it came from. It's just data is at access. And then the furthest right section, we have this understanding that it's separated away again for viewing it. Aggregate data for either historical Power BI reports or live readings. Streaming analytics is a tool Microsoft make to view and analyze streaming data in real time. So the idea is by splitting it into sections, developers can access different bits depending on their needs. People at the live and historical bit potentially they just maybe don't care about intricate device information, stuff like battery readings and things like that. They're just caring about the endpoint data. So we split this up and we began work. IoT Hub is the first initial building block. It's Microsoft's device handling service. So here you can register IoT devices and run them from this platform. So this is a picture I took earlier. It says messages used today. We're not at 0 anymore. It's way higher than that as it's churning through data coming from our office. But the idea here is if you look at the left-hand bar, we can see bits of like devices. So here you could register a device. So this could be like, hey, this is my humidity sensor. This is my temperature sensor. And you can send messages back and forward from them to understand the data it's reading and also change internal settings. Underneath that, we have IoT Edge, which is a home for the edge devices, stuff like that camera I showed earlier, devices that are effectively whole computers. So from here, we can control OS updates and things like that. As we go down, we get to hub settings. And in there, we have built-in endpoints and message routing. So this gives us methods of actually passing data back and forth. We can receive messages from the sensors, something like temperature, and then route that on to another location. This is a lot of Microsoft tools are quite cheap. So actually here we have 400,000 messages a day for free. I believe that is the quota on this version at least. So you can do a lot in the prototyping phase. We're never hitting anywhere near that right now. But overall, the devices are managed here and data flows through it. And the data will hit an Azure function. An Azure function is serverless compute. So if you imagine normal compute, imagine you're writing code in the cloud normally. Typically, you have to go onto your cloud provider, turn a VM on, write some code, do the process, and then turn the VM off again. Serverless compute like functions work a bit differently. In a function, you're not writing a grand and enormous program. As the name suggests, you're writing one function for one singular purpose, one small incremental step. And then this can just be triggered. You don't need to turn VMs on or off. It just will work, hopefully. So these functions can be pointed at IoT Hub, and you can say things like, hey, when an event enters IoT Hub, trigger this function just to run. And this forms the backbone of an element of our data analysis pipeline here. So here, the code itself, we don't need to get totally bogged down. I want to show you some features and some thoughts about why this is good and why it's actually in this diagram. So another fantastic thing about Azure is once you're fully in that environment, everything clips together really nicely. We see here, this is our data cleaning function. The data hits IoT Hub and is passed to this. It's actually in a really nasty format we found. It's nested and weird, and some of it's encoded in strange encodings, and it needs a lot of work to unpick. That's an important point for later, actually. But so the function here is about going through that and unpicking it and cleaning it up. However, we see on line 8 this idea of input blob, func input stream. What I'm trying to point out here is that this function isn't pointed at a path. I haven't hard coded a path in. I'm just telling it, watch a blob storage account, and whenever that's updated, run this function. So it's a bit different. It's nice because you don't have to these paths. You can also point this directly at IoT Hub. So whenever anything hits IoT Hub, we can just trigger this function. And this will clean it up and drop it out somewhere. So this will drop it out into Event Hub, but also storage. Event Hub is an event handling platform. We used to think of it as IoT Hub without the devices, but that's severely underselling it. The idea is all our cleaned and generic event data will now hit here, whether it is temperature and humidity from the sensors or outside weather or dew point from the sensors will all hit here. And a developer could access it all from this one point and subscribe to the events here. And at this point, they don't really have to care about writing a specific API to call the weather or understanding the intricacies of device management. They get all the information here. So with this cleaned up data, we can now pass it on to streaming analytics. So we've gone through this process of getting data from a sensor, cleaning it up, getting into this generic place, and then pointing streaming analytics at it. Streaming analytics will continue Microsoft's great tradition of hyper literal ways of naming their products. Streaming analytics does exactly that. It does streaming analytics on data. It does a range of normal and standard time series analysis over input data. Again, because it's a part of Azure, you can just point it at something and not have the hardcoded information, which is really great. So here I have 2 inputs I can select from. One is blob input, which is a storage account, which is being constantly updated with data from our sensors. And also scissors temperature. That is an IoT hub, which is recording temperatures from one of our meeting rooms in our office called Scissors. The outputs as well, it doesn't have to be paths, which is nice. It can just be directly something you want to access. So this is outputting things directly into Power BI data sets, so we can view them in Power BI. Now, streaming analytics has so much promise, but I found it really restrictive, actually. The language it uses is a variant of SQL with reduced functionality, but added time series functionality. What's nice, though, is you can create your own JavaScript functions to augment the language with, so you can reduce some of that constraints. However, earlier on, I said you had to add the function to clean the data up. If you read the documentation Microsoft write, usually they have this clipping right into IoT Hub. And we tried that. That's why scissors temperature was there. However, because of the reduced functionality of the language, it's actually quite hard to unpick non-clean data. And typically, I find most data doesn't come to you very clean. So we had to add this new structure of functions in between the actual source of data and the streaming analytics job. I went on Reddit and Stack Overflow a lot to try and find other ways of doing this. And one person suggested just chain multiple streaming analytics instances together to form a big chain of them. And through that, you could do the things we needed to because you have multiple effectively levels. However, streaming analytics is significantly more expensive than a function. Functions are dirt cheap. They're effectively free. Streaming analytics is not effectively free. So we like relying and leaning on functions when we can. Finally, we hit Power BI. I'll start speeding up. I have 9 minutes left. Power BI, business intelligence tool from Microsoft, as you'll probably know. It's really exciting. I'm not a Power BI dev, but I do appreciate it. There is 2 versions, in the sense that there is the desktop version, which is really good for historical data, much more complex plots. So we even see there the plots on the right-hand side are much more in depth. This is great for historical data. But there's also Power BI dashboards, which handle live data. So much more simplified things, just floats or time series lines. So you can actually just point Power BI dashboard at streaming analytics outputs, at data sets to plot like this. So we can balance between live reporting and historical reporting. So here, this is just a mock-up, but you have stuff like temperatures and humidities, but you could also imagine some condition streaming analytics doing analysis like, hey, is the humidity indicative that mold is going to be growing? And then you can show mold growth, yes or no, on the dashboard as well. So we rattled through this sort of pipeline, this vertical slice of software that I and some other people have developed, but there's a lot more to the project than that. We have this idea of generically splitting bits up, this sort of very software development concept of atomizing things and making it very, very generic. So I could add in another sensor and not have ripples through the entire pipeline. So we kind of went back to the drawing board, and this is kind of the actual setup we have now that we view as a scalable and deployable solution that we would at least begin our next iterations on if we are deploying things. We take source data in and we are hit with 3 sections, each called cleanup, consolidate, and conclude. So in cleanup, our cleanup functions, they are making the data way cleaner. They're unpicking everything. They're getting into readable formats and sort of making the actual format of the data generic. So there is temperature events, humidity events, dew point events, and IoT hub has been passed in here as well. And these are landing in the sensor hub, which people can subscribe to for raw data or cleaned up raw data. Then this is passed off into a consolidation area where things like we do other calculations like, hey, what are all the sensors in bedroom 1 like? What are all the sensors outside looking like? And that's put into the zone hub. So people who are interested in these zones and these more aggregated levels of data can subscribe to them. And this could be used for reporting, could be stored off in blob storage or a data lakehouse and reported on. Finally, this information can be aggregated again to the house level or street level and also done analysis on using streaming analytics to understand and get actual insight from. So streaming analytics right now, we saw an example where it is looking at windows of time and understanding humidity levels there. So is there mold or not? And that gets plugged into the intelligence hub. So people who maybe aren't interested in live data or aggregated data, all they want is the actual insight, can subscribe to there. So this is what the functions and boiler use cases will be attached to there. I mean, like this sort of format of splitting it up, having different places developers can go to read data, so there isn't this one place with everything in it. It kind of also mimics modern data methodology of a data lakehouse, which uses bronze, silver, and gold notation to tell you how clean data is. I'm going to really rattle through these next 2 bits. I have 5 minutes left. There's loads of excellent tools that we've been using in Azure. There's a tool called time series analysis, again, hyperliteral, which looks at exactly that, time series analysis. I'm slightly skeptical. I need to play with it more. It is one of these products that can plug directly into IoT Hub. Examples you read plug directly into IoT Hub. However, I've been burnt before with streaming analytics, so I'm holding my breath on this one. The tool I really love, though, is Azure Machine Learning, which is their cloud machine learning platform. You can train models, save models, version data, do auto ML. You can do all the sort of model training, ML ops stuff you would expect from a production machine learning solution. So if we see this, we could point this at a storage account to do historical analysis on, or we could train a model and point it towards live data to get live data insights from as well. Importantly, this is a very technical solution, and we are deploying it in the real world, somewhere where people are. So we are very excited to be working with Institute of Safe Autonomy to have access to their ethicists and the team there to work out how to best handle this, guarantee security, guarantee safety, guarantee trust in the system, and an understanding of what people expect from sensors in their own homes. So we started with this question about, can we make social housing safer? And I think over the last year, as we've learned more about this and begun prototyping devices and software solutions, I think we can. I think we can make it safer by reducing mold. The low cost bit is still a bit up in the air as prototypes are made, but the ISA can help us de-risk it and by having a partner who've made hardware and safe systems before. We have this idea from the modern devices of non-intrusion, having battery powered things that are wireless. And we also have this understanding of making the systems where Azure developers, and we've made this platform and this pipeline of work that can handle streaming data. So I'm really excited to see this progress. We actually have, I was talking to a social housing company we work with, and we have over 100 people who are interested in signing up to our pilot program for this. So I am really confident that hopefully we can make a big difference and make social housing safer. Thank you.
Technology was taking me away. Andrew, that was an absolutely brilliant talk. Thank you very much. Just bringing you brought
Just that like one fraction of a second when the talk ends before everyone, all the other like organizers drop in, was like, oh no, have I been speaking? Has my internet connection dropped off? I've been speaking into the void for an hour. But
no,
glad to see you again.
We're still very much here. We've had an awful lot of engagement going on online as well. Please do check it out because there's a few suggestions, questions. I'm going to try and jump onto just a couple of quick ones. We had Brian Foskett. Hi, Brian, for joining. Good to see you, mate. Are you fixed on 3G, 4G backhaul? Have you considered LoRaWAN? Would you require a hub and device? Costs are falling quickly.
So it's right now we it's all to play for. I think LoRaWAN is probably a solution we'll end up going for. We are kind of sort of accepting that ISA, University of York, are the experts here, or whatever partner we go with. I talked about that 3G device because when we bought it, that was the device that was on the market. But yeah, I hear exciting things about LoRaWAN. The coverage is increasing, the prices are dropping. So yeah, I mean, that is probably what the solution will look like.
Yeah, I just implemented a 4G connection, and I just found it disconnecting all the time. And in Yorkshire, particularly, that all the libraries have a LoRaWAN endpoint, so it's like effectively free.
Yeah, I think it'll be something like that.
There's been a couple of reach outs here. Dick Wallace would love to connect with you. Find Andrew on LinkedIn. He'll be there for you. On that, I do need to wrap up the show. Thanks very much for everybody for joining us, and we will speak to you soon.
Yeah. Cheers. Thank you for having me, guys.
Cheers. Bye.
Thank you, Andrew.